Uh, we'll talk about solving trigonometric equations. When we say trigonometric equations, it might be something like this. And yeah, we are trying to solve it for this interval. Or we can say, general solution. So it means like x is in the real number, so all the x values. And sometimes we might have different types of equations, like how about this sine squared x minus cosine squared x equal to, let's say, 1, for example. Or we might have some quadratic form of the equation, like this, for example. We will try to solve this type of equations, and of course our goal is to find a solution set here, and it might be the solution set be it can be given as an interval here. X will be in this interval, or x will be all real numbers. So in this case, there's no restriction on x, so you'll find all the general solution, all x values satisfying the equation. Now these are trigonometric functions, and you will see also other types of trigonometric functions in it, and we'll solve them. Now here are the main strategies. The first thing is, if there's only one trigonometric function and then whose power is 1, then isolate trigonometric function. So you have something like this. Okay, let's say 1. So in this case, you will try to isolate this. This is called isolating it. And then try to solve it. You will search for the angles satisfying the equation. And the other thing is, if there's more than one trigonometric function, or there's a trigonometric function to power greater than 1, then collect all terms on one side and try to factorize. So you have sine squared x equal to sine x. So you will try to send this one here and try to factor it, factorization. And then you set each factor equal to 0, the rest, and then you will try to solve it. And another way is sometimes you might be given some different terms, and you can use trigonometric identities to organize them. For example, I say sine squared minus cosine squared x equal to something here, let's say 1. And what is this? Indeed, this is like cosine 2x maybe, or minus cosine 2x. And by using the identity, you can say it's this. So you can try to change the equation to this, and then you can solve this one. And okay, and also the important thing, as I said earlier, you have to pay attention to the interval of solution. So sometimes, they say, the solution says, find the solution on, find the solution on 0 to pi. So you will just find the solution on this interval, or it will be general solution. So in the general solution, you'll find the solution on a period, on the solution between the 0 and the period, and then add multiples of the period of the function. Okay, we will see that in the questions, how to apply it. Now, let's look at this example. Find the solution set of the equation 2 cosine x plus square root 2 equal to 0 over the real line. So when it says over the real line, it's asking you to find the general solution. Now, the first thing here in this question, it is possible to get the cosine x alone. So we will isolate cosine x. So we will solve it for cosine x. And this will give us cosine x equal to negative square root 2 over 2. So we want to solve this equation now. Now, since it says over the real line, the first thing is you look at the period of cosine x here, and you solve the equation over 0 to 2 pi. So this is the period, so you solve it here from 0 to 2 pi first. Now, when solving it, we will do the reference angle. So we will find the reference angle which satisfy cosine equal to square root 2 over 2. So indeed, this alpha here is the reference angle of x. So here it means if this is the reference angle, it will have this property, cosine alpha equal to square root 2 over 2. We don't take the negative because reference angle is always acute angle, and cosine or trigonometric values always positive for the reference angle. Now from here we can use the inverse cosine, and we can say this alpha should be 45 degrees, or in terms of radian it has to be pi over 4. Now the reference angle of x is at hand. We have it. Now the next thing we have to see is we have to check we have to find the x values between 0 and 2 pi satisfying this equation. So for this reason we use the reference angle. So reference angle is pi over 4. The only question is at which quadrants cosine is negative, because cosine is negative here. Cosine is negative, and now the question is where is x? So you can say by using all STC, x will be in quadrant 2 and 3. So if x is in quadrant 2 or 3, 2, and we know its reference angle is reference angle of x, it's pi over 4. So if it is in 2, then the reference angle will be here, it's pi over 4. So this has to be x should be equal to pi minus pi over 4. But if the angle here, x angle, is in the third quadrant, so the reference angle will be corresponding to this one. Now x has to be pi plus pi over 4. Now we find the x values using the reference angle and the quadrant. So we found it. If x is in the second quadrant, then using the reference angle we say x has to be 3 pi over 4. And here if it is in the quadrant 3, then it has to be pi plus pi over 4. And these are the solution set of 3 pi, the solution set of the equation over 0 to 2 pi. So it's 3 pi over 4 is one solution, and the other one is 5 pi over 4. But if you want to generalize the solution to the all real line, not only 0 to 2 pi, we just take these two solutions, we add k pi to them. So 2 pi k, 2 pi k. So you are taking the multiple of 2 pi. 2 pi is just the period of cosine x. So this set will be the general solution set, because for each k value we'll get a root or a solution for the equation. Now let's do the same thing for this question here. Find the solution set over the real line. So the first thing is tangent x will be equal to minus 1 over square root 3. So you can solve this one, send it to the other side, and divide by square root 3. Now here the period of tangent x is pi. So we will solve it for we will solve it on the interval 0 to pi. Now let's go with the reference angle. Let alpha be the reference angle of x. Now we have this, then tangent alpha is equal to 1 over square root 3. Okay, since it's the reference angle, we do not take the negative here, so it will be positive all the time. Alpha is an acute angle. So alpha, what makes tangent alpha equal to 1 over square root 3? It has to be 30 degrees, or you can say it's just pi over 6. Now, tangent x is minus 1 over square root 3, so it means tangent x is negative. So if it is a negative, it has to be in which quadrant? X has to be in quadrant 2 or 4. But we have another condition here, is we are solving it in 0 to pi, so we put this condition first. And the other thing is coming from this here, x is in also 0 to pi. So which quadrant in here is 0 to pi? It's 0 to 100 pi, 180. It will be Q2 only, not this one, because of this. So x is in quadrant 2. Now, if x is quadrant 2, so I will keep doing it this way. I mean, from here, x is in Q2. And x should be equal to then, okay, what's the reference angle? The reference angle is 30 degrees now, and it has to be 150 degrees, or if you do it in terms of radian, it will be pi minus pi over 6, because this will be pi over 6. This is pi minus pi over 6. So this is the reference angle, and this is the x in this, okay, in the second quadrant. Now, pi is, look at this here. I mean, we did it here. And x is 5 pi over 6. Now, out of, okay, then x is equal to 5 pi over 6. Then we found the solution on, so the solution on 0 pi is just 5 pi over 6. Now the general solution set is, we take this one, we put it here, 5 pi over 6. If you have more, you will take all of them, plus k times pi. Pi is the period of tangent, so you take it from here. Then you will put this pi, and you will count all the integers. So for each integer, k equal to 1, minus 1, minus 2, 2, 3, 5 million, or 1 million, so you the terms here, because we have common terms here, cosine x and cosine x, and don't try to divide them, because if you divide them, then you will lose cosine x equal to 0 solution. So, you know, we never divide both sides with the variable here. We can do just this. I mean, send this one to the other side and try to do the factorization. We have common factors. So just, you know, send this one to the other side. You'll get this one. And here cosine x, and this is a common factor here. So you can factor it. Then after you factor it, you get two solutions. I mean, you get two equations. Like one, cosine x can be equal to 0 here, or cotangent x minus square root 3 is equal to 0. Now, cosine x equal to 0, or cotangent x equal to square root 3. So we have two cases, we have two equations, and we will find their solutions, and then we will take all of them, like we will take the union of them. Now let's solve for cosine x. What makes cosine x equal to 0? Okay, I will not go for the reference angle here, because only the angles on the x-axis, on the y-axis makes 0. So, you know, these are 90 degrees and 270 degrees, and I'm looking for 360 here, 2 pi. So these are the only solutions. Now for cotangent x, I will try to solve it. I mean, cotangent x equal to square root 3 means the reference angle will be equal to the, I mean, if the reference angle of x is alpha, then cotangent alpha will be square root 3, and then alpha will be, okay, which angle makes cotangent alpha? Don't pay attention to this minus issue, and the question here is, which angle makes this? So directly, I'm looking for an acute angle satisfying it, and it will be pi over 6. So the only question here is from 0 to 2 pi, x should be in which quadrants? So, you know, in cotangent is positive in the first quadrant, and cotangent is positive in the third quadrant. So in the first quadrant, the reference angle will be pi over 6. You know, the reference angle is equal to the x itself, the angle itself here in the first quadrant. And in the third quadrant, here, the reference angle will be pi over 6 here, but the real angle will be, the x will be here. So it will be pi plus pi over 6. And then we will write both as solutions. Now, 2 solutions are coming from here, and 2 solutions are coming from here, and we will write all the solutions in one set. And these are the solutions indeed over 0 to 2 pi. So if someone asks you the general solution, the bad thing is, like, for this one, the cosine, it will be 2k pi, because here the period for cosine is 2 pi, and for cotangent it's pi, so you have to add like k pi here, not 2k pi, because here the period of cotangent is pi, and the period of cosine is 2 pi. And then you will put k pi and 2k pi, add to these numbers, and you will say k is an integer, and it will give you the general solution for it. Anyway, this is solved. Now let's go to the other question. Find the solution set of this equation. It says find the solution in this interval and in this over the real line. So let's do A. Do we see a common factor here? Yes. So I will say cosine x times square root 3 plus 2 sine x equal to 0. So this is cosine x equal to 0, and sine x equal to negative square root 3 over 2. So when you solve this one, sine it equal to 0, you will get this one. Now, we have to check the solutions here. X is the angle between 0 to 2 pi, and having this property. So you say x can be pi over 2 and 3 pi over 2, right? Now, when it comes to here, we want to get sine x equal to negative square root 3 over 2. Okay, this is not like 0 or 1, you know, or minus 1. So for this reason, I will go with the reference angle. Alpha is the reference angle of x, and now sine alpha will be the positive value of this, which is square root 3 over 2, and then alpha is the acute angle here. What is alpha? Alpha is 60 degrees, if you remember. So the question comes here, sine x is negative, so x is in the which quadrant? So x is in the third quadrant or the fourth quadrant. So now you have to say, if x is in third quadrant and its reference angle is 60, then what is x? So let's look at here. 60, you add 180, so it will be 240 degrees. 240 degrees will be okay here. This will be 660, 180 here. So it will be in total 250, 240, and this will be like 4 pi over 3. And if x is in the fourth quadrant, x will be, okay, now let's look at here, the fourth quadrant. Graph angle is 60. Now this angle will be what? 300. 300 means five times 60, so 5 pi over 6. Now 5 pi over 3. So this will be 300 5 pi over 3. Now the solution set here over over 0 to pi is pi over 2, 4 pi over 3, 3 pi over 2. I'm not writing them in order, so you can check, like you can multiply with pi and 3, and you can make them in order, but this is fine. Now, after you find them, we want to write the solutions, the general solutions here. For the general solutions, we need the period of this. The period of this one is 2 pi, and the period is 2 pi here. So the good thing is we will add k times 2 pi to all solutions. So we know this one, and the period of cosine is 2 pi. So this is because of this I'm solving. I mean, when I solve, I'm solving for cosine, and I'm doing it for sine. There's a sine issue here, and then in both equations we have cosine and sine. I solved these equations, and now the general solution will be pi over 2 plus 2 pi, or pi over 3, k2 pi. Indeed, we have to say or, okay, or 3 pi over 2 plus 2k pi, or 5 pi over 3 plus k2 pi, and k is integer here. So I couldn't write it well, but this will be the solution here. So instead of the comma, it has to be or, indeed, like this is the correct writing. So this will be the general solution here. Now, let's solve this quadratic trigonometric equation. Now we have a square issue here. We have to solve a quadratic equation. You know, it's something like, okay, this is, if it says like a 2a squared 1, so how can you solve it? Like you can say this a squared is equal to 1 over 2, and a will have plus or minus 1 over square root 2. So it's the same way. We will just do it for sine x. Now let's see. Now first solve for sine x, so you write 2 sine squared equal to 1, and then sine squared x equal to 1 over 2, and then sine x equal to 1 over square root 2, or sine x equal to minus 1 over square root 2. And from here we will try to get the other solutions. But since sine x, I mean, if it says sine x is -1 or 0 or 1, you have to go for like 90 or 0 or 270, this type of angles. Like we call them quadrantal angles indeed, the multiples of 90. So if this is not the case, like you have these, you have to go for the reference angle. So let's look at the reference angle of these equations. I mean, in both here or here, you take the positive part here, the reference angle will be same for both. Like alpha will be equal to, okay, sine alpha 1 over square root 2 means alpha equal to 45 in both cases. And now, after finding the reference angle, what we do here is find the quadrants of x here. So for each equation, for sine x, the quadrant will be what? It's positive, so it will be the first quadrant and the fourth, it's the second quadrant. So you say here, okay, these are two different cases here. The first one is here, the second one is here. And then now, let's see. This one implies x will be in quadrant 1 and quadrant 2. Here, this equation says x here, the solution of this equation should be in quadrant 3 or quadrant 4 because sign is negative here. You remember all STC? All STC. So S positive here, S positive here. So we got this one. And then S here negative and S here negative. So we'll get this one here. Now then, we know the reference angles. The reference angles, both same for it. So for the reference angle in the first quadrant, it's the same of the angle itself. So it will be equal to x. Now in the second quadrant, the ref here, the ref is 45. So x will be this one. In the third quadrant, it will be the ref is here 45. So x will be 225, like 180 plus 45. And at the fourth one, if the reference angle is 45, then this one is 315. So this is 360 minus 45 degrees. So from the reference angle, we go back to the angle. Now these are the solutions of this equation. So the solution set will be, of course, these are the solutions over this interval, 0 to 360. For the general solution, of course, you will add 2k pi to the solutions here because of sine. Find the solution set of the equation tangent squared minus 1 equal to 0 over 0 to 180. Now, you can start by solving tangent squared x equal to 1. So it gives you two equations, tangent x equal to 1 or tangent x equal to minus 1. Now, for this one, the equation has solutions here. From 0 to 180, it's clearly this x has to be only pi over 4 or 45 degrees because in the first quadrant, 10 is positive. So it means from 0 to 90, it will be positive. And from 90 to 180, tangent is negative. So it will be just 45 degrees in this case because it's positive only from 0 to 90 on this interval. And tangent x is equal to minus 1 means the reference angle will be 45. And it will be between 90 and 100, so it will 90 and 180. So 45 will be here. So the solution will be x equal to 135. So you can say it's 45 degrees because it's given in degrees, so we can write the solution set in degrees. So the solution set is 45 degrees and 135 degrees. Now let's look at the solution, this equation. Find the solution set of the equation sine squared minus 2 sine x minus 3 equal to 0, over 0 to 3, so 0 to 360. Now, first, we can try to, okay, look here, sine squared x and sine x. We can try to factor it if possible. Now, solve for sine x. So first, how can we factor it? This might be hard to see, but if you say a is equal to sine x, then this becomes like a squared minus 2a minus 3 and equal to 0. So you can say this is a minus 3 plus a plus 1, and you can do such factorization and then replace sine a with sine x, so you will end up with this. It's one way to do it. Now, this is one way to see it, and it's easy because you can do substitution for sine x, and it will be easy to see it. Now, let's see. Yes, now here in the slide we use u, and then when you use u, it will be u squared minus 2u minus 3, and it will be okay. You can do the factorization here, or you can go with the quadratic formula. Here we go with the quadratic formula. It depends on you. Of course, the quadratic formula always solves it exactly. Now, we get u 3 or minus 1. So here, this when you put here 6 over with the plus, we will get 3, or you get 2 minus 4 divided by 2, it will give you minus 1 and 3. So in this case, u is sine x, we know. Like we can say now, instead of u, we say sine x equal to minus 1 or sine x equal to 3. So we have these two cases, and we want to solve these on this interval. So let's see, sine x equals to minus 1. Since the minus 1 is happening just in the multiples of 90 or 90 or 180, let's check them. But here, definitely, this one is not possible because sine x is always between minus 1 and 1. So there's no solution for it. Definitely, we can eliminate this. We can eliminate. Now, for this one, we can solve it. Which angle makes it? As I said, if it is minus 1 or 1 or 0, you check for these angles, okay, not the reference angle. So here you can check here 0 or 90 or 180 or 270, and here it will be just 270. Quadrant angle means, quadrantal angle means like a multiple of 90 degrees. Okay, so it's on the x-axis, so its terminal side is on the x-axis or y-axis. Now, this is the only one we get, and now sine x is not possible, as I said, no solution, and then the only solution turns out to be here 270 degrees. Now let's try to solve this equation. Find the solution of the equation tangent squared plus 2 tangent x equal to minus 1. Okay, I will do the solution on 0 pi, and then we'll extend it to the real line. We can say by substitution, we can do substitution here. U is equal to tangent x. It will change the equation to u squared plus 2u is equal to minus 1, and u squared plus 2u plus 1 equal to 0. And when you solve it, you will get u plus, or you factor it, you will get u plus 1 squared equal to 0. Then it will give you u equal to minus 1. This is the only solution we have. You can do it with quadratic formula if you want. So then it gives you only one solution, which is only one equation, tangent x equals to -1. And now we want to find x where x is between 0 and pi. Okay, from 0 to 180, if you think. So which angle makes -1? So pi over 4, or like 45 degrees, will make it 90. So okay, let's go with the reference angle, not 90, sorry. Let alpha be ref angle of x, and so tangent alpha will be equal to 1. So alpha should be 45 degrees, or pi over 4, but tangent is negative, so tan -1 means, okay, x is -1, so x is quadrant 2. Why I'm checking quadrant 2 here, this says just check it from quadrant 1 and quadrant 2, because the angles is from 0 to 180, okay? So this is why I'm checking quadrant 1, 2. And here negative happens only quadrant 1, not quadrant 2, not quadrant 1. So the reference angle in quadrant 2 is 45 degrees, we know. So this angle will be 180 divided minus 45, so it will be under 35. So if you change it to degree, it will be radian, it will be 3 pi over 4. Now, after this, we have to write the solution. Okay, writing the solution here is easy, because tangent x has the period pi, and we found the solution over the interval 0 pi. Solution here is 3 pi over 4. So the general solution set, the SS is, okay, solution set is 3 pi over 4 plus the solution over this interval 0 to pi, the period. This is the period here, the important. So it's good that it's given the period pi, and then period is also pi here. I mean, this is a good coincidence that we have pi here. So we have the pi here, so everything looks compatible now. It has to be k pi. K is integer. So this is the solution here. Solution set is 3 pi over 4 plus k pi. This is k pi. And k is in integers. So integer means z. This is the general solution set, the solution set over the real line. So this is a comma here. Okay, strategies for solving trigonometric equations involving fractions and multiples of an angle. Now, so what does this mean? Sometimes we will have like 2x equal to 1, or sine x over 2 equal to 1, or okay, it might be 1 over 2, or any other number here. So how can we find x here? So in this case, we have to be careful about the coefficients of x. So we will see how to solve them here. Now, here is the strategy. Set the fraction or multiple of x inside the trigonometric equal to a new variable. So, for example, if you have sine 2x equal to, say, 1 over 2, and say, let this be u, then you change this one, sine u equal to 1 over 2, and you know how to solve it. And determine the interval of solution of the new equation. Sometimes it says like x is between 0 to 180. And now u will be what then? 2x. So you can say x is between 180 and 0, for example here. And but 2x is a new u. I mean, this is 2x is wanted. So you multiply both sides with 2. So this will be 360. So, I mean, when multiplied, so you got 2x is between 360, 0. So this has to be u is between 0 and 360. And you will solve sine u equal to 1 over 2. And u is from 0 to 360. So you are converting everything to u. Then you will find the solution for u, and then you got the solution here. For example, u is equal to 150, and u is equal to 2x. You got 150, so you get x. So 2x equal to 150, or more values here. So you will set them equal to. You'll find the x values here. This is the strategy, and you will see it in the examples now. Now, let's look at here. Now, the first thing is, okay, you can write it as t, the x over 2 as t, or u as you like. And then we will rewrite this one as t. We'll have 2 cosine t minus 1 equal to 0. Now, the other thing is this one here. X is between 360 and 0, but t is x over 2. So you have to divide both sides with 2. You will get the new interval for t. This is what we get here now. So, this is given here. It means this. So when you solve it over this interval, x is between 0 and 360. When you divide by 2, you will get this. And now we change the equation to this one, see? And we change the interval condition to this one. I mean, everything in terms of t. Now we will solve it, and which alpha makes this. I mean, 60 degree, and cosine is positive only at 60, or not 120. So the only solution will be 60. T is in quadrant 1, so it will be just 60. The reference angle will be this one. Now we will go back to t. I mean x. T is equal to x over 2 as we set here. Then we will try to go back, so which means x is equal to 2t. So t is 60. So 2t will be 120, and we write it as x. So you see the conversion between x and t. X over 2 is t. So x is equal to 2t. We know t is equal to 60, so 2t will be 120. So we solve it this way. So it's a little tricky. We convert x to t first, and everything we change it to t. Then after solving it with t, we get back to x again. Now let's do the same thing for this one. You can say 3x is t. So tangent t minus 1 equal to 0. And now, okay, here we have this one. 3x is between 0, no, not 3x. This guy means x is in here. So x between 120 and 0. So you multiply both sides with 3, will be 0, 3x, 360. Now 3x is t, so you change this one to t. So the question changes to this. Tangent t equal to 1. Tangent t equal to 1. And this interval condition says t is between 0 and 360. Okay, let's say here. Yeah, this is how we did it. Now, tangent t is equal to 1, and t is between 360. Now, alpha, let's say the alpha is reference angle here. Reference angle alpha and tangent t is equal to 1. I mean, where is tangent t here? I mean, t is in which quadrant is it? In quadrant 1 and in quadrant 3, right? So because tan is positive, it's positive. So in this case, if the reference angle here in the first quadrant 45, then already t is 45. In quadrant 3, it will be just 45 here. So the angle will be 180 plus 45. So t will be 225. In Q1 it will be 45, in Q3 225, and now set back to x. Now t we know is 45 or 225. What is t? 3x is t. So now 3x is 45 or 3x is equal to 225. So x is what? 15 and x is what? 75. So these are the angles we got here. So you have to establish the relation between 3x and t. I mean, here we use them here. So x is always t over 3. We use them here.